Okay, welcome back to my class. Today we want to look at identifiers. We have done token, right? And I want to now start showing you the different types of the tokens. So we are going to look at identifiers, and after that we'll look at keywords, and then we'll look at constant and many more, right? So what are identifiers? Identifiers are names that you give to your variables, your functions, and then your user-defined types for easier reference, to make it easy for you to reference them and for you to be consistent in your program. Just imagine having all the human beings on the face of this earth, and then you don't have a name for them. So how do you reference anybody? That's exactly how identifier is. So these are names that you give to your variables. And then there are rules for naming identifiers. First, one is that you cannot use keywords, right? For example, you can't use int, you can't use float, right? You can't use any of these keywords, 32 keywords in Python, and many more keywords that have been added to name an identifier. That is one. Identifiers always start with underscore or uppercase letter or lowercase letter or underscore, right? You can start identifiers with any of these. You cannot use numbers. Cannot use numbers to start identifier, right? You cannot use numbers to start identifier. So, for example, you cannot say two, and then John, right? Or valid identifiers are age, right? Or age. These are valid identifiers, but you cannot start with 2h. This one is invalid. Is invalid, and um, you can say age group underscore group, but you cannot say age group. This one is valid. This is invalid, right? This is invalid. Why this one is valid? This is underscore. This is dash. So you can't name identifier like this, right? You can't name identifier like this, but you can name it like this. Now, another thing again is identifiers have scope, right? You have scope in identifiers. We have scope. We have one, global scope, and then two, we have local scope. We have global scope and local scope. Now, when you create an identifier before the definition of any function, so the identifier is outside before you define any function, that is global. So it means everybody can use it. But when you define an identifier or create an identifier inside a function, then that is local identifier. That is local to that function, right? So you have to be very careful with that. So I'm going to give you an example of these two for you to see in this program. Now, so if I say this include um, stdio.h, right? And then I do this in mark, and then I assign 100 to it. This before I now say int main, then I do this. Then here I can say printf, the value of mark is, then you might not be able to see that far. So let me just write, let me just do it this way. Mark is, or I do this. Then I bring my format identifier. Let me write that properly. D. Then I put this in and I put my comma. Then I bring in my mark. Then I close this and I do this. So I come here and I say return 0. And I close this. Then this is my curly bracket. I close this. Now, this is a global identifier. This is global scope. This is a global scope, right? Now, if I want to write this program and then I bring this into this place, that one will be what? A local scope, because this one, every function that I'm going to create can make use of this mark. But if I define it inside this place, that is local to this main, right? So that is the difference between global and local identifier. So this is a global declaration of this variable. Now this is a variable name. If I decide to do this, now if I now decide to do this mark, I come here and I say int mark, assign 100 to it, and then I say print f mark, then I do my this, then I close this comma, then I put mark here, right? Now I come here and I clean this. Let me just, this one. So this one, this is global, while this one is local. But in real program, I'm not going to have this name and this name outside. System will throw me an error. So I can give a different thing to this one. So I can come here and I can call it a tete, right? I can just call it a tete. Just leave it this way. So this is global scope, and then this is a local scope. So that is just what I want to show you in this program. Now, if I print this out, it's going to print this. But if I put this place as a tete, it's going to print out this one. This one is going to print out this on the screen. Or if I change this place to 50, right? And then I do this, it's going to print out. If I leave it this way and I say mark this, it's not going to print out this mark. Just the way I write my program, it's not going to throw me an error. It's going to work the way the program is. But this one is a string literal that we printed out on the screen, mark. But the value of this that will be in this place would not be this mark. The value will be this etete. That is what is going to be put here. But this one will be printed out on the screen. Yeah, that coincidentally, I just, okay, let me explain this. If I execute this program, it's going to work. It's going to print out this one on the screen, that is 50. That is what we printed out on the screen. But it will be what? Mark. This is what we printed out on the screen. It won't be this one. This is the placeholder to hold whatever value that is going to come, which is an integer value. Now I am asking the processor to go to where this memory location is. So I have given a name to my memory. That is an identifier, which is this. So I am asking the processor, go to the memory location that has this name and print out what is in it. Store it here. But this is a string literal that is hard-coded into the program. So this one will be printed out on the screen, and then this value will be here. But if I change this place now, to mark. Then the value that I will see on the screen will be what? 100. This will now be printed out and it will be like this, same way. So identifier is a name location that you give to, is used to name your variable or your functions or user defined type. So this is an identifier. This is an identifier. That is what I want to show you in this class. Okay, so this is our code block. Now I'm going to create a new project. Okay, so let's create a new project. So I'm going to create a new project. I'll click on the console application, and then I'll click on next. I'll pick my C program. I'll type project name. So I'll call it identifier, right? And then I will save it in this location. I'll click next, and then I'll click on finish. Okay, so this is my code. Then I will open this. It's going to show me the default source code. I can just delete this, right? And then I will say, first, I told you you have the scope. Now I'm going to create the global scope. So I will say int, I say int mark, right? And I will assign 100 to it. Then I will say int main. Then I'll open my curly bracket, which is this one. So okay, so I'll just come here and I'll say main, what am I to write? Here I will just say print f. Then I will do this and I will say mark. Then I will say my format string. I will say percentage %d. Then I will say mark this one. Then I'll come here and I'll say return 0. I'll say return 0 and I'll end that statement. So I can just do this. Now, if I run this, it's going to print out 100 on the screen, right? It's going to print out 100 on the screen. So I will just compile it. I can compile it first, which is this one, and then I will now run it. But I want to do everything at once. I want to compile and run at once. That is build and run. So I will click on this one. So it's going to build it. Then watch this place. See? So it's going to run. So it's printing out mark is 100. All right. Press any key to continue. I just press. Then I can come here. I can change this. So what I did was what? I changed this to Itete, right? And then I come inside here. And then I declared another one, which is mark. And I assign 100 to it. So then I change this one to 50. So with this, if I print again, it's going to, if I compile and run again, to give me output, see, 100 again. Because this is now a local identifier, which is a local variable. Now I want to print out mark. If I come here and I say it is there. So you see, it's going to still leave it this way, but it's going to print out 50. So if I compile it again and run, it will print out 50. You see, it's giving me mark as 50. But if I change this one to there, then I run again, compile and run again, then it will print out there equals to 50. So you can see what is giving me as the output. So that is what I want you to see as a demonstration in this class. So if you have followed me this far, please don't forget to subscribe. If you have not followed me on my Facebook page, you can also do so. So till we see in the next class. Bye bye.